Okay, this is a demo of 4P, fractal line program, fractal fan I'm calling it. When you first start up with the code that I gave you, your starter code, you will not get these two toggle buttons here. You will not get the slider for the center Y value here, and you will not have this initial line displayed here. The other things will be there. The GUI is more or less complete other than those three pieces. You need to tie the, the listener values when they occur to your code to do the response. I'm going to start the demo by turning this jitter off. It will initialize to something other than 0. And I'll make the height a little smaller. So the basic fractal algorithm says take this line, find its midpoint, and when you recurse one level of depth, let me turn off the fan so we can see. Take that midpoint, displace it by 10% of the length of the line, and create two lines. And then when you go to one more level of recursion, each of the previous lines, 10% of that, the midpoint of that will be displaced by 10% and moved up there. This was the previous, that line doesn't change place, that was there, it just stays there. We put a midpoint here and a midpoint there, displace it by 10%. At level 3, we'll take each of these lines, multiply their length by 10%, find the midpoint, displace that midpoint there. And so if we go up to 3, and then at 4 we'll do each of those, at 5 we'll do each of those, at 6 we'll do each of those. Let me go back a little bit. If we increase the percentage, then of course each line gets further and further away from its starting point. Each point gets further away from the midpoint that it started from. And we can get pretty fast display up to, well, at least to 10, but then you can't see the lines anymore, so it's not worth it. Notice that I'm asking you to draw a small ellipse on at the endpoint so that they do show up when you don't have too many of them, and they don't dominate the length of the line. Now this is pretty boring. So these sliders here, well, this one, as you see, varies the height that you use for the point above where it started. So that gives you some variation. This says, okay, let's not just strictly take the midpoint, but let's randomly perturb that, jitter it a little bit around where it should have been. And it also applies the same jitter variation to the height, so not every subdivision of a line at any given stage will go exactly 10% or 12% or whatever the number is above its position, but that value, the nominal value, will be modified by some other percentage of its value times a random number. So as we raise the jitter, that is how much of a variation are we going to allow, both the height and the position along the line that subdivides it gets varied to semi-randomly, and that gives us more interesting patterns. So here we go to the next resolution, and all those points can vary both in how far they were from where they started and where they are along the line. And we just get a little more interesting sets of patterns, and we can have very large displacements and very large jitters. Yeah, we get, with large jitters, we get lots of crossing over of the line, but more interesting patterns. Okay. Let's go back to a simple display. in addition to drawing the line, which is what we did here, you also need to draw a triangle. Make triangles out of each line becomes one edge of a triangle, and the third point will be a common point that will start out, the common point will start out as the midpoint of this line, roughly. I think I made it exactly that, just approximately the midpoint here, approximately halfway across, and at the same height. Well, you can't see that triangle, but there is a triangle being drawn here. It has 0 size. But as soon as we generate our new point, we now can see 2 triangles here, one formed by this edge and that point, and the other by this edge and that point. And then we color them so we can see them as we go into more depth, recursive depth. We get more interesting patterns, and as we change our nominal height and we change our jitter, we get different shapes. Not terribly different, but approximately different. An important thing for the assignment here is to make sure that the colors are reasonably consistent once you get a certain number. When I first did it, I just generated the colors randomly all the time, or in a single cycle. And then every time I changed the parameter, all the colors changed too, and it made it hard to kind of see how the parameter affected the fan when the colors changed. So when you start rendering at any given point, you want to always start with the same color. If you have a series of colors that you go through, always start, when you start the rendering, with the same color, so that this leftmost triangle of mine is always red, and it makes it easier to keep track of the transformation from one version to the other. You can use other schemes. You could have all of these could be shades of the same color or shades of a few color. It's up to you, but just try to make the consistency from one display of the same number of triangles have the same mapping of colors to them, so you can see how that, understand how it varies when you change things. The other thing that you can do is this central point. This slider moves that central point just to give some interesting behavior in what the shapes look like. One other thing, this seed, so you have a random number generator. Random number generators start with a seed, and once you fix the seed, the sequence of numbers you get is constant throughout. The numbers look, they're randomly generated, but the sequence is actually the same as soon as you start with the same seed. That's very important for debugging. For this particular assignment, that's not a big deal, but just as a matter of practice, you should always start your random numbers with a specific seed that you decide, so that you can get predictability as you're debugging. And I have you change the seed, and the seed gives you different series of random numbers, so your fan changes shape and your line changes shape. But if we go back to, you'll always get the same fan if you start with, say, seed 0. You'll always get the same series of fans if you start with seed 1. This isn't terribly important to the program, but you should make sure that you use whatever this value is and then for your seed when you're doing it. I think that's about it.